One exciting new feature in the 7.2 release of AUD is the ability to create native AutoCAD tables driven based on any data within the AUD data model. This video provides a basic introduction to get you started. AUD tables are based on two things: an AutoCAD table style, which controls how the cells within the table as well as the overall table is formatted, and an AUD table definition as defined using the AUD options function. I'll go through this from start to finish so you can understand the whole picture. Here's my test drawing. It has 5 transformers, all different. And for this example, let's say you want a simple table that looks like this. It lists all of the transformers that are currently in the design with 5 columns. The transformer's ID, which in this case is stored in the name number field, the transformer's description, the type of transformer, loop versus radial, the transformer's phase count, and the secondary voltage. And, mainly to serve as an example, I've made the text in the first column red. Part 1 is to create an AutoCAD table style that defines how this table will look when created. I'll type table style at the command line. In the out-of-the-box AUD template, there are 2 existing table styles, standard and legend. I'll create my own, which I'll label Trans Table 1, and I'll base it on the standard table style already defined. We'll do more with this new table style, but first I need to take a detour. I'll save this style. Now I'll type table at the command line to insert a blank table. I'll choose the table style Trans Table 1 and indicate I'm starting with an empty table. Now I'll set the number of columns to match the number of columns that I want in my transformer table, 5. I'll set the column width for now to what I'm going to guess is the average width of the columns wanted in model units. I'm going to set this to 3 for now. Now I'll click OK. AUD asks for an insertion point and I'll insert my blank table. AutoCAD wants input, but I'll press Escape. Here's my empty table template. Now I'll select the whole table and take a rough guess at column widths starting from the right. I'll make the secondary voltage column narrower, the phase count column quite narrow, the transformer type can also be pretty narrow, and then the ID column can also be narrowed up, and that leaves the description column quite wide, which is probably what I need. Remember, this is a quick exercise, but what I've done here is create a table template. Now again, I'm going to type table style at the command line. I'll choose Trans Table and click on Modify. Now in the upper left, click on this icon to select the table to start from. Set the table you just created. This is the key to getting the column widths defined. Yes, I know it's not obvious. I'm going to do one more thing in this table style definition before saving it. I'll click here to create a new cell style. I'll name the cell style Data-Red, and I'll switch to the text tab here, and I'll change the text color to red. Finally, I'll click on OK, and then I'll close the table style editor. Great. On to part 2 to create the actual AUD table. At the command line, I'm going to type AUD options. Now you'll see this new item on the left, Table Layouts. And when I hover the cursor over it, there's a plus sign that appears. Click on the plus sign. Change the name here to Transformer List. In the Style field, I'm going to enter Trans Table. This is the primary link between the AUD table definition and the AutoCAD table style. The table style determines the table's format, which is basically an AutoCAD underlying function. And there were 3 possible AUD-related elements that need to be defined: feature sets, grids, and cells. In this basic table example, we're going to only cover feature sets and grids. I'll start with feature sets. First, I'll be honest, I think the name feature sets is a little confusing, and I'd prefer you think of this as being the data source definition section. On the right, it says collection, which means you can define a bunch of stuff here. I'm going to select this line and click on the ellipsis to the right to continue. Whenever you create a new table definition in AUD, a default entry is created. This is handy, and we're going to then change it a bit so you understand what's really happening. First, I'm going to change the name to Transformers. I'll set the operation to query, meaning that the information will appear in the table based upon a SQL query against AUD's internal database and not a selection you make on the screen. And under filter class, I'm going to type in EL Transformer, which is AUD's internal name for the table that contains all the transformers in your design. While I'm at it, I'll fill out a couple other fields here. Order by has already defaulted to ascending, but in terms of the field in EL transformer that I'd like to use for sorting this table, I'll set the order by attribute to name number. Yes, there's more here, but remember I'm going for simple in this video, so click OK. Now I'll select the grids row, which also says collection. Think of grids as being grids of data queried from the database. The feature sets collection defines the data source. The grids section defines how that data will then be presented. Click on the ellipsis. The first screen you see here defines the grid you're creating. This grid will start in column 0 on the first row of the table. We're not going to worry about these settings in this video. Instead, we'll select the columns entry, which is yet another collection. I'll click on the ellipsis and define the columns that I want to show in my table. As mentioned earlier, AUD has already created a default table, and so it's added 3 default columns. Now we get to define what's actually in our table. Remember, for the first column, I want to show the transformer identifier, which I mentioned was stored in the name number column. So the attribute I want out of the database is name number. Now remember I said I didn't like the name feature sets. Think of this second row as the data source, and the one we've named for our data source is transformers. So transformers is what goes here. It's the data source. I'll make the header ID because it's short and sweet. And finally, remember I said I wanted to make the first column red, so I'm going to pick my special red text style data-red. Switching to the description column that was already predefined, I'll change the feature set name to transformers because that's where our data is coming from. And I'll put in a title of, well, description. For the next column, I'll change the attribute value to ID transformer type, which is the field pointing to the domain for transformer type. Again, the feature set, the data source, is transformers, and I'll make the header type. Now I'll click on Add to create another field. The attribute in this case is going to be phase_count. Feature set is again transformers, and for a nice short header, I'll use $PH. Finally, I'll click on Add again to create my final field. My attribute will be ID_voltage_2, the secondary voltage field. The feature name set is again transformers, and the header in this case will be voltage. Now a quick aside for the database experts listening to this. If you know the underlying AUD database well, you'll know that ID voltage2, and for that matter ID transformer type, are domain fields. They don't actually contain the data. They contain a pointer to the specific domain record that has the actual value. However, within the AUD table implementation, you'll still get the right results here. AUD sees that this is a domain reference and returns you the referenced value from the domain in the table. Okay, we're done. I'll click OK a few times until we're back in the drawing. And now for the test. I'll type AUD table at the command line. There's only one table defined to choose from, transformer list. Select this and place the table, and there you go. There's a lot more that the table's functionality can offer, including the ability to combine data from multiple database tables within AUD, the ability to create totals, subtotals, and other individual values, and the ability to query and export data from AUD database tables to CSV files. But these are going to be the subject of other videos in this series.